So, in general, you got a function y equals f of x and a function y equals g of x, and you got their graphs, maybe? You want to find out where the graphs intersect, right?
Yeah.
Well, if y equals f of x and y equals g of x, then f of x had better equal g of x, right?
Yeah. And f of x is better equal g of x.
Solve the equation f of x equals g of x. Okay? Now that might be an exponential equation. It might be a quadratic equation. It might be a completely bizarre equation nobody can solve. Very easy.
Do a radical
Yeah.
equation.
If I want the intersection of a linear function with an exponential,
Might not be.
you can't solve it.
Do a radical function.
You'll never put it into standard exponential form so you can change it to
We
logarithm.
never did one.
Okay? And your only option then is to understand how the graphs work. Okay? Understanding how the graphs work, being able to do an approximate graph and see where the intersection point is, about where it is, that gives you a basis for some trial and error. Now, if you learn calculus, there's another method called Newton's method, where you use a slope function. Okay, and I'm not going to tell you any more about that. And in an applied calculus course, you might not even see that method, but you might. Okay? So there are methods of solving those equations approximately that work pretty well. Another method, of course, is to graph them on your graphing calculator and figure out where the points the point where the graphs intersect. That's perfectly valid outside of this course. Okay? In this course, we learn how the functions behave. Then, any fool can learn to use a graphing calculator and make these graphs in a graphing calculator. If you know how to interpret the graphs, if you know what the graphs are telling you, then you're in good shape. Okay? Okay, well, this is how you find points of intersection. You can expect to have some problems where you try to find points of intersection, right?
Can they all be linear?